All right, today's lesson 30 is on repeating decimals. What's our objective, class? Get ready?
Repeating decimals.
Repeating decimals. So a repeating decimal is where a pattern of decimal numbers repeat itself, like 27, 27, 27. The way we write it for shortcut is we say 0.27 and we put a bar over the 2 and 7 because that's the repeating chunk that continues in that pattern. So we say 0.27 repetend. How do we say it? Get ready?
0.27 repetend.
Good. 0.27 repetend. 2/3 we've memorized that it's 0.6666 dot 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 dot. It goes on forever. So as a shortcut we write it 0.6 with a bar over just the 6 because the 6 is the thing that repeats. So we say 0.6 repetend. What do we say, class? Get ready?
0.6 repetend.
0.6 repetend. So how do we create a repeating decimal? Where do they come from? Well, all repeating decimals come from a fraction or ratio, a rational number, a number divided by another number. That's how all repeating decimals are created. So let's find out if we did 1 divided by 6. Let's divide it. It says 1 divided by 6, right? So many students keep reversing. Well, how do I do 6 divided by 1 or 1 divided by 6? Well, just say it out loud. That'll help you. 1 divided by 6. So the 6 goes in front of the bracket. 6 divides into the 1. It won't go. So we're going to put a decimal and bring it up. 6 goes into 10 once. 1 times 6 is 6. We subtract, we get 4. We bring down the 0. 6 goes into 40. 6 times 6 is 36. We subtract, we bring down another 0. 6 goes into 40. 6 times 6 is 36. We subtract, we bring down another 0. Wait a minute. 40, 36, 40, 36, 40, 30. It's going to be the same every time. So now we kind of realize every time it's going to be 0.66666. So I'm going to rewrite as a shortcut 0.16 repetend. Just the 6 repeats. 0.16 repetend. How do I say it? Get ready?
0.16 repetend.
Good. 0.16 repetend. Remember, denominator goes into the numerator. Denominator goes into the numerator. How do we say it? Get ready?
Denominator goes into the numerator.
Denominator goes into the numerator. If I had 2 and 1/3, don't I know 1/3 is the 0.33333333? We've done that a lot, right? So really, if this part is equal to 0.3333 and forever, I could shortcut that to say 0.3 repetend. And my whole number part, I can just write it right in front. So 2.3 repetend. Emma.
In what instances would you round? Like go 0.33?
Great question. Okay, in baseball, they always have batting averages with 3 decimal places. So you say, hey, it might have been, they had 3 up to bats and 1 successful attempt, so their average is 1/3, but they'll never write it as a fraction. They'll round it to 3 decimal places, so they say 0.333. Okay, so great question. And in our homework, it'll tell you when to round. We're going to do some rounding as well. All right, here's a RISE or State Common Core Standard Number Systems Standard number 1. You have to know the 3 possible outcomes of a rational number. Now remember, don't panic when you hear rational number. Rational is a ratio. Ratio is just a fraction. We know fractions. Well, look at this fraction. If you divide that, you get an integer. You can divide this fraction and get a terminating decimal. Or you can divide this fraction and get, let's do it, 3 divided into 10. The 3 will go into 10 3 times. 3 times 3 is 9. We subtract, we get 1. Bring down the 0. Oh, 3 into 10 again. 3 times 3 is 9. We subtract, we get a 1. Bring down the 0. Wait a minute. It's the same every time. Okay, so I'm getting 3.333333. Can I just write this as 3.3 repetend?
Yep.
Okay, so your 3 possible outcomes are an integer, a terminating decimal, or a repeating decimal. Always. Those are the only 3 possibilities. Okay? integer, terminating, and a repeating decimal. So as long as you see that. Well, what if you got a number like pi? That couldn't have come from a rational number. Pi is irrational. You can't turn a number like pi into a fraction. Or like the square root of 17, it's kind of a weird non-terminating, non-repeating. You can't make a ratio out of that. So we're going to try some ordering least to greatest with repetends or repeating decimals. Okay, least to greatest, I look at 0.3, 0.3 repetent, which I know means the 3's go on forever, and 0.33, which terminates. I want to compare them, so I'm going to stack them with 0 so I can really compare digits. So I'm going to put a 0 here, and a 0 here and here, and go, okay, first digit, they're all tied, they're the same value. Second digit, it's easy to see now, this is my least value. So, whoops, 0.3, I'm going to write it in the original form. This is my least value. Now I'm taking care of that. So now which is the least one out of these two? Tied, I have to go over to the next digit. I can see here, this is the least value. So I write 0.33. In the original form, there's no 0 on the end, so I'm going to keep the original form. Done with that, and that's my biggest one. In the original form, it's 0.3 repetend. Give me a thumbs up if that makes sense and you agree. Okay, thumbs down, Ms. Boone, you lost me, you're going way too fast. Okay, I think we're okay. All right. Rounding. Rounding's pretty cool. All right. The trick is it says round to a certain decimal place. The decimal place they want us to round is the 1,000th place. What? How many digits is in the 1,000th place? Think. How many digits is that? You ready?
3.
3. Very good. I don't have 3 decimal places, but wait, they do. Because I know that repetend means that 3-7 keeps repeating. So I'm going to just write a few out, ... so I've got room to work. And I'm going to find where is my 1,000th place. It's right here. That you said the 3rd place. Tenths, hundredths, thousandths. Then circle the digit next to it and say 5 or more make it soar, less than 4, or 4 or less let it rest. I'm going to soar or rest. Okay, ready?
Soar.
Soar. Good. This 3 is going to round up. So I write 1.374. Done. Do I have 3 digits? Yeah.
Yes.
Did I round to the 1,000th place? Yes. Okay. How about this one? Let's write out a few places. 7, 7, 7, 7, 7, 7. Okay. You got the idea, Mrs. Boone. 3rd decimal place over is right here. That's the digit we're going to round. Circle the next one. 5 or more make it soar. 4 or less let it rest. Soar or rest. Get ready?
Soar.
Soar. Good. Thank you for staying with me and paying attention. 7, 7, so that'll round up to an 8. That's rounded to my 3rd place. Your turn. Write it on your paper. Put your pencil up when you've got it. Write out a few digits. Write out a few digits. Put your pencil up when you've got it rounded to the 3rd decimal. 3rd decimal place or the 1,000th place. All right, let's call on Kaylee.
9, no.
What's my next couple digits?
Oh, it's 19,
Is it 9292? 2222, okay. All right. 3rd decimal place?
Yeah.
The 2.
Yeah.
Okay.
And it's just stays
It stays a 2. What happens to all the rest of the 2's?
They go by.
They just go away. They're zeros. We don't need them anymore. Okay, how many of you had 0.922? Okay, awesome. You're getting this. Very good. All right, now we're going to do something super exciting. The next concept is not in your Saxon book. However, it is on your state standard test. It is a Common Core standard. It's number systems, number 1. How to convert a decimal expansion, which repeats, eventually into a rational number. What does that mean? It sounds fancy. It means take a number like 0.333 that repeats and turn it into a ratio, a rational number. Well, we have this one memorized, so that one's easier. But what if I gave you a number like this one? How would I turn 0.555, I forgot my dots. How would I turn 0.55555 into a ratio? Ethan?
maybe take only just the first decimal, like the first digit after the decimal, and then divide it by 10.
You're actually, you got some good concepts in there that we're gonna work with. There's gonna be a 10 in here and we're gonna be moving a decimal place. Okay, so there's a trick. I mean, I could plug all day in numbers in my calculator, like 7 divided by 5, is it 4 divided by 5, is it 11 divided by 5, is 5 even in it? We don't even know. It could take all day. So here's a cool trick. Since one digit's repeating, we're gonna multiply it by a factor of 10 because there's 1 0 in the 10. We're just gonna move things over one place. Times both sides by 10. That would give me 10 times x, I'm gonna write it up here, 10 times x equals 10 times this number. Well, I know when I do a factor of 10, it moves the decimal over one place. So I'm gonna write that. 5.5555 dot dot dot. Don't I also know my original x is 0.5555 dot dot dot? Give me a nod if you're okay so far, you saw what I did. Times by 10, I moved the decimal, and I rewrote my original right underneath it. This is super cool. This is like one of my favorite things to teach because it's just a cool thing. All right, why am I doing this? Because we're going to manipulate things. We're going to like cheat a little bit. Not cheat, but kind of work with the numbers to change them. If I subtract the top equation minus the bottom equation, look at my decimal. 5 minus 5 is 0. 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 5 minus 0 is 5. All my decimals are gone. Carry down my equals. 10x's minus 1x is how many x's? Think. Get ready? 9. 9x's. Look at that. 9 times some number equals 5. And that's the x I've been looking for. So to solve for x, we're going to divide by 9. Divide by 9. 9's go away. X equals 5 over 9. So wait, you're telling me 5 9ths is that? Type it in your calculator. 5 divided by 9. Okay? 5 divided by 9. Give me a nod when you see it and you can confirm. Yes, 5 divided by 9. 5, type in divide 9.
This is
Oh,
blessed.
5. It's totally cool, huh? You get to do one next.
Someone could literally just type in 0.555
Rachel.
and say they saw it.
There's a 6.
Oh, and
That's
the
what they
end,
rounded.
your calculator can't fit all in the repeats, so it just rounds it.
Yeah,
Okay,
there's a 6.
your turn. You are now going, oh, I just erased it. Shoot.
What the heck? Now I have to be smart.
Well, I was going to leave it up so you could use the cutter. Will you, some of us have this memorized, but will you use that same method, times it by 10, subtract the original from the bottom of it, give me a fraction. What fraction is this represent? And I'm going to write down what I had up here. I had 10x equals. Okay? So as soon as you've got that, raise your pencil. All right, Winry, what do I write first?
Okay, so it will be, we times both of the sides by 10, so it will be 10x equals 6.6666.
Okay.
And then it would be 1x equals 16666. And then you would minus them,
Okay.
and you 6.6666 minus 0.6666 equals 6.
Equals 6, because all of these turn into 0. Okay, good.
And then 10x minus 4x is 9x.
Excellent.
And then you divide both sides by 9 to get x alone. And then x equals 6 over 9, but you can reduce that to x equals 2/3.
Awesome. So we're going to get rid of a 3 in there. The 2 on top, a 3 on the bottom. Super cool, huh? How many of you guys are 2/3? I watched around, almost everybody had it or almost had it. Awesome. Very good. In the last case, I want to just briefly mention this, and then we'll let you guys start working on practice problems. What if there's 2 digits repeating? Can this method work with 2 digits? It actually can. We're going to times by 100. 100x would make it 45.45, 45. Nod your head if you agree. that true? Because 2 zeros would move it over 2 times. Okay, good. Then my original is x equals 0.45, 45, 45. 45's left. Wait a minute, 100x's minus 1x, 99x's are left. I have a fraction that fast. That's super cool. We're going to divide by 99. Divide by 99. We get 45 over 99. I see a common factor of 9. I get 5 elevenths. And you can type it in. 5 divided by 11 is 0.45454545. Totally cool, huh? Okay, awesome. Unfortunately, there's no homework problems like this. It's just not in the Saxon. So in spring, before our test, we're going to practice this a little bit more so you guys remember how to do it. Okay, practice set, page 194. Please use the practice sets on the bottom.